For now, though, let's spend the rest of our time together looking at Oracle memory structures. Memory structures should lead you to think this is volatile. This is data that's stored in the server's random access memory, or RAM, and therefore is in jeopardy of being lost if, for instance, somebody trips over the power cord and the Oracle server just goes down unexpectedly. The two memory structures are the SGA, or System Global Area, and PGA, the Program Global Area. The System Global Area, or SGA, is defined as a group of shared memory structures that contain data and control information for a single database instance. Like I said, that gets a little complicated when we deal with pluggable databases, but for now let's constrain our discussion to the traditional single instance Oracle database. The Program Global Area, there's actually going to be many of these as you'll see in just a second, is a memory region that contains data and controls information for a server or background process. And here's a key difference. Access to the PGA is exclusive to the process. What is a process? Well, that's a good question actually. Let's proceed and I'll tell you. In the System Global Area we have various components. And actually I'm going to break out into the web browser again to show you something cool. If you would, pop open a web browser and use Bing or Google, whatever your favorite search engine is, to search for Oracle Database 12c Interactive Quick Reference. This is such a great interactive site. As you can see, it's divided into several categories, looking at different views. I want to draw your attention to database architecture. What this will do is show you this Mondo architecture diagram that is just very complicated when you first look at it. When you double left click, it gives you a zoom view where you can come in closer. Here we're looking at different caches in the System Global Area. If you double left click a cache, you can see on the right it gives you a little blurb to define what it is, and then check this out. You'll see a link that goes directly to that location in the Oracle documentation. Now, heads up, the Oracle documentation is outstanding. I've been in the IT industry for a number of years, and I've never seen any documentation as meticulously maintained and accurate as the documentation for Oracle Database. It's awesome. That having been said, throughout this training, I'll always be giving you references to books, media, websites that I think are helpful to you as a developing Oracle DBA. Please know that I'm not being paid to give you any references, and I'll never reference a book that I haven't actually read or a website or product that I don't actually use and visit. Let's briefly discuss the major components of the System Global Area. Like I said, this is a memory area that's all volatile information. So what is most important to me are things like the first two items here, the database buffer cache. This is a memory cache that stores copies of data blocks that have been read from data files and have not yet been written back to the data files. Maybe they don't need to be written, but just as likely they were. So you have various stages of the buffer cache. For instance, you might have a user who runs SQL to pull back a bunch of rows. Well, Oracle is going to fetch those rows from the data files on disk. Temporarily thereafter, those rows will be stored in the buffer cache, so if another user runs a query that references those rows, Oracle can satisfy the query by grabbing the data from the cache. Therefore, you get great input-output performance by using the buffer cache. The buffer cache also stores changes, so it's crucial that Oracle periodically flush the contents of the buffer cache, that is to say changed data blocks, back to the data files where they're recorded permanently. And we'll circle back on that in the next module. Another buffer that's extremely crucial is the redo log. This is a separate memory area that works in a circular fashion that stores all changes made to the database. So as users execute SQL to do DDL, that's data definition language, create, alter, drop, etc., DML, that refers to things like insert, update, delete, those changes are recorded in the redo log, first in the buffer, just in memory, and then when a checkpoint occurs, those changes, those SQL operations, are flushed to disk in your redo log. And hopefully you've got your Oracle database configured to archive your redo logs, so that in the event that you have to recover from a backup, you can bring your database to as close to the time of the failure as possible. Other pools, there's several that aren't quite as important in my humble opinion. The shared pool is sort of a catch-all bucket that Oracle uses. Shared SQL, the data dictionary or metadata cache is storing its stuff here temporarily. The large pool is what I consider an overflow area that stores memory that can't be fit in the shared pool. Remember that Oracle owns Java, so there's heavy reliance upon Java throughout Oracle products. The Java pool stores Java Virtual Machine and Java code in a temporary cached way. Remember, cache itself refers to a storage area, and the idea with cache is that we want fast I/O instead of having to go to disk. Streams, you're not going to use at all unless you're using Oracle Streams replication. Nowadays, Oracle has deprecated Oracle Streams and instead wants you to use one of their products called Golden Gate if you have need to have warm or hot standby replicas of your database. And then the fixed SGA is just an in-memory area that's used by Oracle for internal housekeeping.